this is Tiago from Coderversity, and in today's video we will learn Elasticsearch versus SQL differences. In this video you will learn what is SQL, what is Elasticsearch, the core differences between SQL and Elasticsearch, why you should learn SQL, why you should learn Elasticsearch, and when to use both SQL and Elasticsearch together. So, what are we waiting for? Let's dive in. So, what is SQL? Let's start with SQL. SQL stands for Structured Query Language, and it's been around since 1970s. SQL is the standard language for managing and query data in relational databases like MySQL, PostgreSQL, or Microsoft SQL Server. In a relational database, data is stored in tables that consists of rows and columns. Think of a spreadsheet with a well-defined structure. Each row is a record and each column is a piece of data. So, imagine that you are running an online store that's growing really fast. You're storing all your data, customer information, product details, transactions in a traditional relational database. But now you're getting hundreds of thousands of search queries in a day. Customers want to find products quickly based on vague keywords, but your select SQL database is slowing down. What do? Well, this is where Elasticsearch comes into play. Today, we are going to explore why learning both SQL and Elasticsearch can not only make you more efficient, but also give you the flexibility to handle different data challenges. Let's dive into how each technology works and why you should care about both. You could have a customers table where each row is a different customer, and the columns can be the name of the customer, the city, and the country of the customer, like the customer, like you can see in this example. What makes SQL powerful is the ability to easily filter, sort, and aggregate data. For instance, let's say you want to find all customers who made purchases in the last 3 days. With SQL, you could write a query like this. Select everything from customers where, and we make a condition, for example, purchase data is higher than the now date minus an interval of 30 days. That's pretty simple, right? SQL is excellent for structured data where relationships between tables are important, like linking customers with their orders. But, as good as SQL is, it has limitations when it comes to large-scale, unstructured data or fast search queries. Let's talk about Elasticsearch. Elasticsearch is a distributed search and analytics engine that's designed for speed and scalability. It's built on top of Apache Lucene and excels at handling large volumes of unstructured or semi-structured data, like logs, documents, and most importantly, text. And instead of storing data in tables, Elasticsearch stores data in JSON format, and it's optimized for full text searches. Let me give you an example. Imagine you're searching for a product in your online store, but you only remember a few keywords. With SQL, you would have to write complex like queries to match part of the product name. But in Elasticsearch, this is much easier. It uses inverted indexes to match search terms quickly and efficiently, even with partial or fuzzy matches. For example, if someone types blue shirt without the I, for example, instead of blue shirt written correctly, Elasticsearch will still find the correct result by using fuzzy matching algorithms. This is something SQL isn't optimized for. Here's what an Elasticsearch query might look like for this scenario. So, the index where we were getting The information is called products, and we do a search. And we type in a JSON where we set our query, also in a declarative way that will match the field name of the index and the query value that we will be using will be a bad written blue shirt, and we will introduce an automatic fuzziness without editing its values. It looks something like this. This flexibility is why Elasticsearch is widely used for search functionality on websites where fast real-time querying is critical. Now that we've introduced both SQL and Elasticsearch, let's compare them side by side. First, SQL is all about structure. It works best when your data is neatly organized into rows and columns, like customer records, inventory, or sales data. SQL is transactional, meaning you can update, delete, or insert records with guarantees that these changes will be reflected across the system. This is why relational databases are often called ACID compliant. ACID stands for automacy, consistency, isolation, and durability are the key principles. In contrast, Elasticsearch is designed for quick, flexible, and not so structured search over large amounts of data. It's schemaless, which means you don't need a rigid structure like SQL. Instead, Elasticsearch can handle both structured and unstructured data, making it perfect for full-text search, logs, and monitoring large datasets. The real distinction, though, comes in performance. SQL databases can slow down significantly with large datasets or complex queries involving joins across multiple tables. But Elasticsearch scales horizontally, meaning it distributes data across multiple servers, making it capable of handling massive datasets and performing searches in real time. Here's a concrete example. Suppose you have an e-commerce platform with 1 million products. In SQL, searching for a product by name across that many records could take several seconds. And that is not a really good performance, right? But in Elasticsearch, the same query could return results in milliseconds because of how it indexes data for fast lookups. Now, why should you learn Elasticsearch? On the other hand, learning Elasticsearch gives you a completely different skill set that is essential for real-time search and big data analytics. If you work with large volumes of text data or need to perform fast, complex searches, Elasticsearch is the perfect tool. It's widely used in applications where speed is crucial, like search engines, like Google, for example, log aggregation, and real-time monitoring. For example, companies like Netflix, Uber, and eBay use Elasticsearch to power their search functionality. Elasticsearch also supports aggregations, but instead of structured data, it focuses on analyzing unstructured data, like logs or documents. Here's an example of how Elasticsearch can help with analyzing log data from a web server. Instead of table, we have a similar structure called index. And let's imagine we have the logs index and we put the keyword search to do a search. We put a size of 0 and we set some aggregations for the top IP addresses. And remember, this is based on a JSON input with the terms That is, terms is like a search where we don't analyze the text. So it searches like keywords, the exact match with by the field client IP with a size of 10. Don't worry if you don't know right now the details. This query returns the top 10 most frequent IP addresses accessing your websites. Elasticsearch's ability to scale across clusters of servers makes it perfect for use cases where you need real-time analytics across millions or even billions of data points. So, when to use both SQL and Elasticsearch together? Here's the takeaway, the key takeaway. SQL and Elasticsearch are not competitors. They are different tools. They complement each other and they have different objectives. So you don't need to use one or another. While SQL is perfect for structured relational data, Elasticsearch excels at full-text search and real-time analytics on large datasets. In fact, many applications today use both systems in tandem. For example, you might use a SQL database to handle your e-commerce store's transactional data, like customer orders and inventory, while using Elasticsearch for product search or logs. Let's say a customer wants to search for a blue shirt, like we did in the previous example. In your backend, you could be using Elasticsearch to handle the search request, but once they find the product and add it to their cart, SQL is used to store the details, the order details in this case. Combining both technologies allows you to leverage the strengths of each system. Now that we understand what SQL and Elasticsearch are and how they differ, let's talk about how you can actually use them in a .NET application, and in the next few minutes I will walk you through how to integrate both SQL and Elasticsearch into your .NET project so you can take advantage of both technologies. First, let's look at SQL. And if you want to watch a live coding project being made using SQL, check out the video in the description. But first, let's look at SQL. Using SQL databases is straightforward thanks to Entity Framework Core, which is Microsoft's Object Relational Mapper, an ORM, and with the Entity Framework Core, you can map your database tables to C# objects and use LinQ. And if you want to know a bit more LinQ as well, check also my video in the description that is regarding LinQ to interact with the database. Let me show you a simple example. Suppose that we have a SQL database storing customer records in a table called customers. Here's how you can define a customer entity and query the database in .NET. Let's give a code example. So, customer, which will have obviously, the primary key called customer ID, our first name, that will be a property of the customer, also a last name, and lastly but not least the final property for the date of birth, that will be a date time type called date of birth. Now we write the class of app dbContext, which inherits from DB context from Entity Framework Core. And we will have a DB set of customers, which will be called customers, and we will have a getter and also a setter, of course. Now we override our onConfiguring method from the DB context, and we personalize it to do what we want. We receive DB context options builder, and again, this is just an example, okay? This is not structured and not following any architecture or pattern per se. And we will call options builder, and our options builder will say that we are using SQL Server, and you just put your connection string here. Now, to access our DB context, our app DB context in this case, we'll rewrite a class customer service that will handle the connection and the data manipulation of SQL Server. We will have a private read-only app DB context, which is the same type that we declared here, called context. And we will write the constructor for customer service and initialize our private context with the one that we receive by constructor. Then we'll make a method, an asynchronous method, and again, if you want to know a bit more about asynchronous programming, check also my third video on the description. Task list customer that will get our customers asynchronously. And this will of course return the customers from the context. In this example, you are using Entity Framework Core, and the Nugget package to install the Entity Framework Core is in the description, and all the future references and packages that you might need, you can encounter also in the description. So don't worry about it. In this example, like I was saying, we are using Entity Framework Core to define a customer model and the DB context class, which represents our connection to the database. We are also defining a customer service class to fetch data from the customers table. The getCustomersAsync method here returns a list of customers by querying the database with the toListAsync method. It's a clean and simple way to work with SQL databases in .NET without having to manually write SQL queries. But remember, while this is great for structured relational data, if we are handling large amounts of unstructured data or needed fast search capabilities, we would need Elasticsearch. That's what we will look at next. Let's move on to Elasticsearch. In .NET, we can use the Nest client, which is the official .NET client for Elasticsearch. Nest provides a fluent API for communicating with an Elasticsearch cluster, indexing documents, and performing searches. So, let's say that we want to store and search customer documents in Elasticsearch. First, we need to install the Nest Nugget package. You can do this via the Package Manager console in Visual Studio or any similar technology for the IDE that you are using, or using the command line. Once that's installed, we can configure Nest in our .NET project and connect to an Elasticsearch cluster. Here's how we can define a simple model for our customer and indexing it in Elasticsearch. Let's say we have the ID. Let's actually modify this one. The first name, the last name, and the email. That will be also a string. And then we will remove the appdb context because we are not using Entity Framework core anymore. And we will make use of the customer service, but let's call it Elasticsearch service instead, to make here a clear distinction. So here we will have our Elastic client called client, and instead of the context we will not receive anything, and we would declare the settings of the connection in declaring a new connection settings instance with the URI of http two slashes localhost with 9200. That is the default port for Elasticsearch, with the default index of customers called customers. And then we would initialize our client with the new Elastic clients, and we will pass the settings that we just set now. Now, an insertion is the same thing as indexing something. So let's create an asynchronous method to index a customer asynchronously. And we will receive, of course, a customer. And we will get as a response the return that the index document async method passing the customer retrieves us. And as a search method, we will declare a task which will receive a nice search response that is native from the Elasticsearch library, that will contain a customer or more, and we will call it search customers async, and we will of course receive the query as a parameter. And for that we will return the JSON that we saw in the previous example, but with .NET syntax. So in this case, search async of the type customer, in which the customer will query. So let me put the dot here for better readability. And that query will have to match what? The field first name of the entity customer, and execute the query that we receive by parameter that can contain other specifications. And in this example, we first define a customer class that represents the document that is what an entry on Elasticsearch index called, and we will store it in Elasticsearch. Then, in Elasticsearch service, we will we use the Elastic client to connect to an Elasticsearch index running on localhost 9200 port. We define then two methods: the index customer async, which indexes or inserts, if you want to understand better, a customer document, and then the search customers async, which performs a full text search on the first name field using the match query. This is how easy it is to integrate Elasticsearch into your .NET applications. Whether you're dealing with product catalogs, customer records, or logs, Elasticsearch gives you the speed and flexibility to search through massive datasets quickly. And so, why is it important to learn both SQL and Elasticsearch, especially in the context of .NET development? First, SQL, like I said, is essential for working with structured relational data. It provides a reliable way to store and query data, and .NET's entity framework makes it incredibly easy to work with SQL databases through C# objects. However, when it comes to fast searches, especially with large datasets or unstructured data like text, logs, or documents, SQL can struggle. That's where Elasticsearch comes in. Elasticsearch is optimized for search, offering near instantaneous results when dealing with large volumes of data. By using both technologies together, you can build more efficient, scalable applications. SQL handles the core transactional data, while Elasticsearch powers a fast and flexible search functionality. Whether you're working on an e-commerce platform, content management system, or analytics dashboard, mastering both SQL and Elasticsearch will allow you to tackle a wide range of data challenges. Finally, let's look how you can use both SQL and Elasticsearch in the same .NET project. This is a very common scenario in real-world applications where SQL is used for transactional data and Elasticsearch is used for search functionality. Let's take an example where customers in our SQL database also need to be indexed in Elasticsearch to support fast searching. After adding a customer to SQL database, we can also index them in Elasticsearch to keep the search functionality up to date. So let's say that this will be again the customer service. Actually, let's keep the Elasticsearch. Let's keep this and go back to where we had the entity framework structure. And now let's add on the customer service. Let's keep, instead of Elasticsearch service, this constructor, and we will have the Elastic client, and we will also have the app.db context. Where here the client is initialized, but also the db context equals to context that we will receive by parameter in the constructor. And now we can add the customer sync, and when adding, we are not only indexing but also saving the changes to the customers and add the customer like we had before. Now we have both options, so it stores in the SQL and in the Elasticsearch using the context and the Elastic client. And now we need to save the context changes, and this will take care of the entity framework core part, and this of the Elastic one. And in the search customers async, let's call it like that, we will search instead of the SQL. Let's get from Elasticsearch because we want a faster response for the amount of customers that we have. So we use the Elastic client, that is called actually client. Actually, we already have it implemented, silly me. And then we just return what we want. So to add, we are adding in both SQL and Elasticsearch, and to search, we only use the Elasticsearch. In this code, we've created a customer service class that interacts with both the SQL database and Elasticsearch. When adding a customer, we first insert the record into the SQL database using the context entity framework, and then we immediately index the customer in Elasticsearch using the index customer async method. This ensures that our SQL data and Elasticsearch index remain in sync. When searching for customers, on the other hand, we use the search customers async method to query Elasticsearch, which provides fast results, especially for full text searches. And that wraps up our tutorial. I hope you found these projects helpful and that you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it, and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.